Hello Precalculus students, and welcome to a video on graphing parabolas and circles from standard form. So first of all, let's focus on parabolas, and let's just look at the two possibilities, and that's a regular parabola that you're looking at here and a sideways parabola that you're looking at here. This one, of course, being sideways, you picture a sideways parabola, it is not a function. Now, the equations that I have here, I decided after printing these notes that this is not the ideal way of remembering these equations. In this one, you can make the vertex KH, but just makes things more confusing. So we're going to actually rethink this. Okay, so what we're going to do is, and this might be familiar, this might be the way you've seen it before, but we're going to just put the K on the other side. Instead of trying to get this to look like a function, which is right now solve for y, which you could put in your calculator, for example, because it's a function, we're just going to write it in a less direct or an implicit function notation, which is going to be y minus k equals a times x minus h squared. All right, now this is just a better way because now you can just think whatever you're subtracting is your hk, and that's the vertex. Now the other nice thing about this way of doing things is that if you remember that since the h is the x-coordinate of the vertex, it's got to go with the x. And the k is the y-coordinate of the vertex, so it's got to go with the y. So when we write this alternative form, this sideways parabola, we're going to write x minus h equals a times y minus k squared. And this we're really switching these. So this is just a mistake, actually. Just think of that as a mistake. It's probably the easiest way to do this. Okay, so then the vertex is still hk. This is just a square here. So this way the vertex is always hk, the h is always next to the x, and the k is always next to the y. Okay, so that's a start. All right, now let's look at what this parabola does. Now we know that if a is positive, that this opens up. We already know that. And if a is negative, then this opens down. That's just review. And when the absolute value of a is greater than 1, then the graph, that's a vertical stretch. So the graph is vertically stretched, and when this is a fraction, then that's vertically compressed. Okay, here we have kind of what you would predict. If a is positive, if a is greater than 0, then it's going to open to the right. And if a is less than 0, it opens to the left. And the same thing, if a is an improper fraction or something greater than 1, then you're looking at a horizontal now, it becomes horizontally stretched, and then a fraction becomes vertically stretched, or sorry, horizontally compressed. It actually does both, but we'll go with horizontally compressed. That's the focus. All right, so here's two parabolas. One of them is a vertical parabola and the other is horizontal. Let's just graph the vertical parabola first by using the tools that we just talked about. So the first thing is we notice that h goes with the x, k goes with the y, and this would actually be, I guess we would write it like this, y plus 1 equals negative 2 times x minus h. To be consistent with our formula, h is 2 and k is actually a negative 1. So the vertex is 2, negative 1. Okay, we know that a is, this is going to be vertically stretched, and we know that it's going to be vertically reflected, and we also know, well, we already moved it down, so we don't have to say that again. So we have 2, negative 1 is right here, and being reflected, it opens down, so it opens downward, and being stretched vertically, instead of going over 1 and down 1, it's going to go over 1 and down 2. And there's our vertical stretch. And you can continue that because we know that if we went over another one, normally we would go 1, 1, and then 2, 4. But now we have to go twice as far. So we'd go over 1, down 2, and over 2, down 8. So that would be 1, 2, 3, 4, 5, 6, 7, just right off of the graph. If you wanted to graph that much detail, which why not? We can fit it, we should do it. So there's the vertically stretched, vertically reflected vertical parabola with a vertex of 2, negative 1. Let's look at the horizontal. Okay, So this one, let's write it in the form that we see above, which is x minus h. So we're going to call this x minus 4 equals negative 2 times y minus 1 squared. Based on where the x's and y's are, this is horizontal. This is still a 4, 1 for the vertex. So the vertex is at 4, 1. And let's draw that. And this one is going to be, now remember, everything on a sideways parabola is on the outside is the horizontal stuff. So this would be a horizontal reflection, which means it opens to the negative direction. So it's going to open this way. And it's also stretched. So we would normally go 1, 1 for if you want to think of a parent function, it would go 1, 1. This one's going to go up 1 and over 2. So up 1 over 2 right there, down 1 over 2 right there, and we're on our way. And then when we go up another one, we would normally go over up 2 and square it, so we go over 4 units, 1, 2, 3, 4, but we double that to 5, 6, 7, 8, and it's right there. And the same thing with symmetry, it would be right there. So there's our sideways parabola. So it's something like, I missed it, and then going this way. Okay, that's it for the parabola fun. We're going to move on to the circles, which I think are going to be more familiar and a little bit easier. So here we've got graphing a circle that's already in standard form. And we can recognize right away that the center of the circle is at 2, negative 1. Remember HK? Oh, we've got it right here. Sorry. I forgot to tell you. I forgot to refresh your memory on this. So it's minus H and minus K. So the center is HK. And the radius is R. So whatever's over here, you have to take the square root of it for the radius. Radius R. Okay, so let's look at what we have here. So we have the center is 2, negative 1. So we know that R squared is 9, which means R is 3. So this is like an easy version of an ellipse because you don't have 2 directions to go and you just have to go 3, up, down, left, and right. It's all the same. So we first find the center here, and then go up 3, down 3, left 3, and right 3. And just connect them. I keep missing my points, but you get the idea. I missed both of them. Okay, so there's the other one. You know, I think I'm going to graph the other one with the protractor. I mean, with the compass, since I'm missing so badly. Okay, this one is not in standard form, so we're going to have to do a little bit of algebra first. So let me do that algebra down here, and we recognize first that it's a circle because the x squared and the y squared have the same coefficients. They're both positive. So I'm going to group the x's, group the y's, move the last constant number to the right side and complete the square. So I have 4x squared plus 20x plus 4y squared minus 24y equals negative 45. And all I did was just, like I said, regroup and move that 45, subtract it from both sides. Okay, let's take out the 4 and set it up to complete the square. So we have 4 times x squared plus 5x plus something to complete the square. Okay, this is just the same as these two terms until I put something there. And then I have another 4 over here, so plus 4 times y squared minus, and 4 times 6 is 24, so minus 6y. Leave space to complete the square, and that equals negative 45 plus whatever we added there plus whatever we added there. So 2 of them. What are those numbers? Let's see. This one unfortunately is odd, so we have to take that as a 5 over 2 squared, which at this point, after you've practiced a little bit, it's not too bad. This is 4. Write that 4 times 25 over 4. And this time they completely cancel. So when we add the piece that we need to complete the square, we're really adding exactly 25. So we have to balance that on the other side. On this side, we're going to take half of this and square it. So that's going to be plus 3 squared is 9. which means we're really adding 4 times 9, or 36. Okay, one more step here, and we have, or one more step to complete the square, and then another step to write it in standard form. So we have 4 times x plus 5 over 2 squared plus 4 times y minus 3 squared. Remember, it's half of this. Okay, and then that equals, and if we add all these numbers together, what do we get? We get 16. And then the last step would be divide everything by 4. So we want to get rid of these with a circle. With an ellipse, we go the other direction. We make this into a 1 because we're going to have to look at those denominators. But for circles, we don't want that. So we divide everything by 4. And the best way to write this then would be, here, I'll just do it right like this. Okay. Would be x plus 5 over 2 squared plus y minus 3 squared equals 16 divided by 4, which is 4, or 2 squared. Okay, now we have that. We know that the center is negative 5 over 2, comma 3. We know that the radius squared is 4, so r equals 2, and we're ready to graph. All right, so negative 5 over 2 is negative 2.5, so right about there, and then up 3. So from there and up 1, 2, 3, there's our center. And we go 2 in each direction. I take it back, I'm not going to use a compass because this is too small to effectively graph with a compass. Up 2, down 2, 1, 2, so that's left 2 and right 2. Now it's harder to miss when the points are that close together, so I should be able to do this one. There we go. There's our circle. And this is critical information. Sorry, I circled the center and the radius. Critical information for the circle that should either be on the graph or very near the graph. And that's it. I hope you found this video helpful.